Hi there. In this video, we'll be learning how to graph an ellipse the easy way. So basically, in graphing an ellipse, our main problem is that given an equation of an ellipse, suppose this one, how does this become a graph? So that is what we'll be working on in this video. To do this the easy way, we will be needing three parts: the center of the ellipse, as well as the semi-major and minor axis of the ellipse. So, if you don't know how to obtain these parts, you may check out the previous video on this playlist, I think, if I'm not mistaken, since I presented and teach there how to obtain these parts of an ellipse from its equation. Aside from this, we'll also be needing the orientation of the ellipse. So this is also obtainable from the equation of an ellipse. So you may check that video as well, since I have a previous video on that. Now take note that since we are only dealing with how to graph an ellipse the easy way, this won't be the most accurate. But in graphs, the important thing is that we know how it looks like, or we have a great representation of how it is and its behavior. So given that, we remark that this won't give the most accurate graph of the ellipse, but it is just enough to give us an idea how the graph looks or is. So good, so without further ado, let's have this example. In here, we're given x squared over 4 plus y squared over 9 equals 1. Again, our goal is to graph this one. So before we start, you may pause the video for a while so that you can try this first on your own based on the idea that I presented earlier on the parts and the orientation. So good. So let us start. To solve this, we first take note that we can actually express this equation and write it as x minus 0 squared over 2 squared plus y minus 0 squared over 3 squared equals 1. We did this since from this form, we can now easily obtain its parts. Starting with the center. To obtain the center of an ellipse, it is just given by these two out here. So this out here will represent the x coordinate, while this one out here would represent the y coordinate. So we'll have here the point 0, 0 for its center. Next, let's obtain the semi-major and semi-minor axis. To obtain these two, starting with the semi-major axis, we just check the denominators, or more specifically, these two out here. The square root of the denominators, the original denominators. From these two, we just take, since we are dealing with the semi-major axis, we take the larger one between these two, and that would be 3. So we have the semi-major axis to be given by 3 units. Next, for the semi-minor axis, we just take the other one, which is 2. So we'll have here 2 units. So that is the length of the semi-major and semi-minor axis respectively. Now we have the 3 parts. The last thing to check is the orientation of the ellipse. And we're going to obtain this one as well from the denominator a while ago, this one. So given these two, to obtain the orientation, we just inspect which between these two is larger. Clearly it is 3. And since 3 corresponds to the denominator of the y variable, this means that we know that the orientation of this ellipse must be vertical. So again, you may check the previous videos as I discussed out there how to obtain the parts and the orientation of the ellipse from its equation. Given these 3 parts and the orientation, we can now graph this ellipse. So let's have a graph out here, there, the plot, and suppose that these out here represents the units. So this is 1 unit, 2 units, 3 units, and 1 unit, negative, that. To graph this ellipse, we start by plotting the center of the ellipse. So this one is just 0, 0, so it is just at the origin out here. Next, we use the orientation and the semi-major axis. So since this one is oriented vertically, we use the semi-major axis to count along the y-axis since it is vertically oriented. So that is the thing that you need to remember. That's why the orientation is important. So given this semi-major axis 3, we count 3 units up and 3 units down from the center. So take note of that one. That is crucial in obtaining the correct graph for this ellipse. So let's count up, 3 units up and 3 units down. So we'll have here 1, 2, and 3, then 1, 2, and 3. And let's plot the points out here. So we'll have this one and this one. I hope that this is visible since I think this color is quite close to white. So just bear with it. Apologies for that. And yeah, we do the same for the semi-minor axis. Now for the semi-minor axis, we count along the x-axis. Since this one is oriented vertical, instead of y, along the y-axis, for the semi-minor axis, we count along the x-axis. So like the semi-major axis, we count 2 units to the left and 2 units to the right this time. So let's go. So we have here 1 and 2, then 1 and 2. And let's plot the points out here. Again, we count from the center. That's why it is important to plot the center first. And from here, what we do is we just connect these 4 points out here. But yeah, keep in mind that it should look like an ellipse, so you can't just like create a line out here to connect these points. So that is wrong. Again, keep in mind that we have an ellipse out here. So if we would connect these 4 points, it would look something like this one and this one. And of course, don't do it like a line. So that doesn't look like an ellipse already. And then this one and this one. So this doesn't look quite an ellipse, but if we do it properly or do it like nicely, the curves, it would look something like this. And so this out here represents the graph of our equation x squared over 4 plus y squared over 9 equals 1. And so that's how we graph an ellipse given this equation from this to this. To end this, so I have an exercise prepared out here. So this one. So this is an exercise that you can try to work on respectively. So in here we have x minus 2 squared over 25 plus y plus 3 squared over 16 equals 1. Basically, the idea on how we obtain this one is quite similar to our example. It's actually similar. The difference is that we already have a value for the center, which is this one out here. So basically, when you plot the graph, so we have this The center isn't from the origin, so just be mindful of that one. Won't be there. Would probably be around, I guess here, something like that. There. And then take note that since the denominator of the x out here, the x variable, is larger compared to y, the orientation for this ellipse is now horizontal. So just keep in mind those things in answering this problem. So yeah, I hope you enjoyed and learned a lot from this one. If you got stuck in this problem, feel free to comment down below any feel free to comment down below if the part that you are stuck with, and I'll try my best to reply and explain how it works. And if you have a graph, we can't really send that in the comment section, I think. So you may email it, I guess, and I'll try to check and verify if it is correct. So yeah, that's it. And I hope you learned a lot from this one. So yeah, that's all for this video.